For number 4, we want to graph f of x equals 3 to the x minus 4. So we know that this is an exponential graph, so the horizontal asymptote is down at -4, and if we plug some values in for x, we can find a couple points on our graph. So if I plug in 0, I get 3 to the 0 minus 4, which is 1 minus 4, which equals -3. So I have a point at 0, -3. And if I plug in 1, I have 3 to the first minus 4, which is -1. So the graph would look like this, and that is closest to choice B. For number 5, we have 2 to the -2 minus 3x. We know that the horizontal asymptote for this would be 0, since there's no number on the back. So now we just need to plug in a few points to see where this graph is. So a good point to plug in would maybe not necessarily be 1, but a -1. If we plug in a -1, we have 2 to the -2 plus 3, which is 2 to the first. So we have the point -1, comma 2. And another good point to plug in would be 0. So if we plugged in 0, we have 2 to the -2, which is 1/4. So 0, comma 1/4. So if we look at our choices for the graphs, it looks like that it is A, since we have a point at -1, comma 2 and a point at 0, 1/4. For number 19, we want to evaluate the natural log of e squared. Natural log and e are inverse functions of each other, so if they're ever written right next to each other, they cancel out. So the answer would just be 2. We can eliminate number 20 since it's a calculator problem. And the next one is graphing a natural logarithm. So when we graph a natural logarithm, we want to remember that a natural logarithm graph has a vertical asymptote wherever the logarithm will go to 0. So we know that this has a vertical asymptote at x equals 5. Also, we can use shifts to determine where a point would be on our graph. So in the parent function of a logarithm, we normally have an x-intercept at 1, comma 0. And the shifts of this logarithm are telling us to move this point 5 to the left, 5 to the right, and then up 3. So we'll go 1, 2, 3, 4, 5, and up 1, 2, 3. So our point will move here. We have a vertical asymptote at 5. The logarithm is positive and it's increasing, so our graph will look like that. Which looks the most like choice D. Oops. D. For number 22, we have e to the natural log of 3. So just like the last problem, e and natural log are written right next to each other. So they cancel each other out, and the final answer would just be 3. For number 23, we want to find the domain of y equals the natural log of x plus 2. We cannot take natural logs of any negative numbers or the number 0. So in that case, our domain would have to be x is greater than -2, and an interval notation that would be -2 to infinity with open parentheses. For number 24, we have to graph an exponential and a logarithm. So our first graph is y equals -e to the x. So we know that that graph would have a horizontal asymptote at 0. Now we have to plug in a couple points. So if I plug in a 0, I get -e to the 0, which would be -1. So I have a point of 0, -1. And if I plug in 1, I have -e to the first. And we want to remember that e is about 2.718. So I get negative 2.718. So I have a decreasing exponential function. For the logarithm graph, I want to remember that I have a vertical asymptote, and it's wherever the logarithm equals 0, so it would be a vertical asymptote at negative 1. And then I also want to remember about the shifts. So usually we have a point at 1, 0, but this is going to shift 1 to the left and down 2. So my logarithm will be further down, and it's still increasing. So I want my logarithm to increase and curve.
That was so fun.
For number 29, we want to condense the logarithm. And since the two logarithms are being separated by addition, we can condense them using multiplication. So we have log base 9 of 41 times 33. And 41 times 33 would be 1353. So our choice would be D. For number 30, we're going to condense the logarithm, but this time the logarithms are separated by subtraction, so they would be condensed with division. So that would give us log base 4 of 5, which is choice C. For number 31, we want to expand the expression. So the first thing that we would want to do is simplify the exponents within the square root. So if we have the square root of x to the 4th, it will become x squared. If we have the square root of y to the 6th, it'll become y to the 3rd. And if we have the square root of z to the 8th, it will become z to the 4th. Now we can separate the two terms in the numerator by addition. And the term in the denominator by subtraction. And then the last step would be to take the exponents and move them out in front. So we would have 2 log base b of x plus 3 log base b of y minus 4 log base b of z, which would be choice B. Number 32, we're also expanding the logarithm. So I am going to rewrite the 6th root of y as y to the 1/6. And then I can separate these two terms with subtraction. And then the last step would be to move the exponents out in front. So my final answer would be choice C. For number 33, we're condensing again. So I'm first going to take the numbers that are out in front, the coefficients, and move them into the exponents of the term that we're taking the logarithm of. I'm not going to FOIL or do anything like that. That's a little bit too much work. The last thing I want to do is notice that these two logarithms are separated with subtraction. So I'm going to condense them using division. So my final answer will be choice B. For number 34, I am solving the natural log of x minus the natural log of 1. Whenever you have two logarithms on one side, we want to condense them. So we end up with the natural log of x divided by 1 equals 0, which is the same thing as the natural log of x equals 0. Now we want to get rid of the natural log, so we're going to exponentiate using e. So I have x equals e to the 0, and anything to the 0 power equals 1. So my answer is B. For number 35, I want to get the two terms to have the same base so I can equate the exponents. So I notice that I have 1 over 27 and 9, and I can turn those both into a term having a base of 3. So I'm going to change 1 over 27 to 3 to the negative third, and I'm going to change 9 to 3 squared, but that's still raised to the 8x plus 2. So now I'm going to multiply my exponents together. I'm going to multiply 8x plus 2 by 2. So I have 3 to the negative third equals 3 to the 16x plus 4. And now that my bases are the same, I could just equate the exponents and solve. So now I have negative 3 equals 16x plus 4. So negative 7 equals 16x. So my final answer would be negative 7 over 16, which is choice A. For number 36, we want to do the similar tactic. So I'm going to change 1 over 3 to 3 to the negative 1. That's still raised to the x. And 3 to the 7th equals 243. Oh, I'm sorry, it's 3 to the 5th. There we go. So now I have negative x equals 5. So x equals negative 5, which is choice D. For number 40, again, we have 2 logarithms and we need to condense them before we begin to solve. So I'm going to condense them using division. So I have log base 3 of x plus 2 over x equals 3. And now I want to get rid of the logarithm, so I'm going to exponentiate. The base of the logarithm is going to become the base of the exponent, and 3 is going to become the exponent. So I have x plus 2 over x equals 3 to the third. So x plus 2 over x equals 27. So x plus 2 equals 27x. So 2 would equal 26x. And my final answer would be 1 over 13. So this would be what the answer would look like on the final, since we are not using calculators, but that is the same as choice B. For number 41, the first thing that I want to do is divide by the 9. So I have the natural log of 3x equals 21 over 9, and that reduces to 7/3. And now I'm ready to get rid of the natural log, so I'm going to use an e to exponentiate. So I have that 3x equals e to the 7/3. And then the very last step would be either to divide by 3 or to multiply by 1/3. So your final answer on the final will look more like x equals 1/3 e to the 7/3. And the last problem, number 42, we only have one logarithm, so we're just ready to exponentiate right away. So the base of the logarithm is going to become the base of the exponent. So I have 4x plus 14 equals 8 squared. So 4x plus 14 equals 64. So 4x will equal 50. So x will equal 50 over 4, which reduces to 25 over 2. So A would be our answer for 42.